Hello and welcome. In this video, we're going to look at the introduction to z-scores. I'm going to kind of build into what a z-score is. There is another video that follows this that has a lot more detail on z-scores, and we'll leave that to all of the nitty-gritty details. I want this one to just be a quick, short introduction to z-scores. So we looked at this example in the other video that goes into a lot more detail, but this one says that the scores on a college entrance exam have an approximate normal distribution with a mean of 52 and a standard deviation of 11. According to the empirical rule, we can figure out all this stuff. And again, we've done that. A through E are in the other video. Done in other video. So please take a minute to watch that if you haven't. I want to focus on F and G and then build into what we should be knowing about z-scores. So F says, if there were a test score equal to 90, could we consider such score an outlier? Well, a score of 90 would be above the top portion here. And if you remember back from the other video where we talked about the empirical rule, this top portion is approximately 0.15% of the data values. So in the very, very, very top tail of this. So this score of 90 is even higher than some of this 0.15%. So this score of 90 is quite uncommon in this distribution. So I would say yes, we can consider this score an outlier. Yes, 90 is an outlier. Now the question asks, how many standard deviations above the mean is a score of 90? Well, here's the mean, mu. Here is one standard deviation above the mean. Here's two standard deviations above the mean. Here's three standard deviations above the mean. And again, I defined where all of these values came from in that other video, so please make sure you watch that. What we know is a score of 90 is more than 3 standard deviations above the mean. How many more than 3 is it? And that's where this idea of a z-score comes from. It's not 4. If it was 4 standard deviations above the mean, it would be a score of 96. But it's not 96, it's between 85 and 96. So it's somewhere between the two. What we can do is figure out the number of standard deviations by using the z-score formula. And that's what we're going to do with this. So in order to find this, we know that 90 is the score. We're given that the mean is 52. So we can figure out that the difference between the score of 90 and the mean of 52 is 90 minus 52. Let me just grab my calculator to make sure I do that right. I think it's 38, but I just want to make sure. 90 minus 52 is 38. Yes, 38. So we'll say that the deviation between the score and the mean is 38. But we know that the standard deviation is 11. So we can take that deviation score, that change between the value and the mean, and divide it by the standard deviation. This should again be between 3 and 4 standard deviations because our value is between 85 and 96. And it is. We end up getting 3.4545, or approximately 3.5 standard deviations. All right, a little bit of notes here. It says any data value that is more than 3 standard deviations away from the mean can be considered an outlier. So anything that's more than 3 standard deviations from the mean can be considered an outlier. And anything that's more than 2 standard deviations from the mean can be considered unusual. If we look at our picture here, 2 standard deviations, I'll highlight in blue on both sides. Anything more than 2 standard deviations would be in the very small portions of the graph. Anything more than 3 standard deviations, I don't think I chose the same color. Anything more than 3 standard deviations will be even in the smaller little tails here. So very little portion of the graph, or very little portion of the distribution, would be in those tails. So So that's what we're trying to figure out, is how many standard deviations the data value is away from the mean. And that calculation is our z-score. Our z-score indicates the number of standard deviation that the data value deviates from the mean. There's a formula here. It's in the notes. It says the z-score of a data value is the data value minus the mean divided by the standard deviation, or the score minus the mean divided by the standard deviation. And we can simplify it to the formula that you see on the screen, which is the z-score of a population is the x value minus the mean divided by the standard deviation. Again, the other video will go into a lot more detail. I want this one to be rather quick. So, example 3.18. We just watched a video, or we should have just seen the video, on these two students, Kai and Cooper, who are trying to compare their performance to the rest of the class. We know that Kai and Cooper both scored below the mean. We want to now figure out what is their z-scores. Again, the z-score just represents the number of standard deviations away from the mean. And in the other video, we calculated these deviations. We just didn't call them z-scores. So if you go back and think about what we just talked about in the other video, basically what we calculated is exactly what we're doing here. So I think I used blue for Kai, so I'll do that here again. We'll do the z-score for Kai. It was the score minus the mean divided by the standard deviation. And we got, I believe it was 0.15. In this case, since we're actually doing the subtraction here, we want to make sure we're doing the subtraction in parentheses if you're using a calculator. It would be negative 0.2, but I forget what it is offhand. 0.15 divided by 0.7 was a z-score of negative 0.214. And for Cooper, we can do the same thing. Z-score for Cooper, it would be 77 minus 80 over 10. Again, if you're doing this in the calculator, make sure you put the top in parentheses. You do the deviation first. This would be a negative 3 over 10, which would be, just ran out of room a little bit. Sorry. Equals to negative 0.3. So, same calculations we did before. The only difference is that now we're calling them z-scores, and also notice that I included the negatives with these calculations because now we are using the z-scores. Please do take a moment, or about 15 moments, and watch the next video on z-scores, where we'll go into z-score calculations in a lot more detail.